Hey, welcome to another super exciting episode of Voices of Video. I am Mark Donnigan, and today I am joined by Dennis Mungai from Cires21. Dennis, thank you for joining us.
Thank you, Mark, and thank you for the warm introductions.
Awesome. Well, I'm really excited for our conversation. You know, we have spent a little bit of time talking about what all you guys are building, and so we're gonna dive in. But why don't we start by telling the audience who you are, specifically what you do at Cires21, and then give a brief intro of Cires21.
Absolutely, that would be a pleasure. I am Dennis Mungai, and my current role at Cires21 is on the research and development of the video encoding, packaging, and handling infrastructure that we have built over the years at Cires21. The role mostly encompasses on a lot of research and near constant iteration, because this field is it's a moving target. It's always been
Yes,
a
it
moving
is.
target. And
Yeah.
Cires21 in particular has had very deep investments into R&D efforts in both video processing, audio, and also up and coming with a lot of AI integrations. So this is going to be a mainstay of what we do
Amazing.
towards not only improving on the product stack that we have, but also contributing our work towards making better tooling for video.
Mm-hmm. Yeah,
Yes.
amazing. Now, where is the company based?
The company is based in Madrid, Spain.
Madrid. Okay.
Yes.
Yeah, beautiful. I've been to Barcelona. I have not been to Madrid. It's definitely on my list. So,
Definitely.
yeah, amazing. And I know that I don't think you're in Madrid. So, are you the only one that works, outside of the office, or is it a distributed team as well?
It's a distributed team. It is a distributed team.
Amazing.
Yes.
Yeah. That's the way of technology today, right?
Absolutely.
NETINT is similar. I mean, we definitely have three primary offices, but there's team members located around the world. So yeah, incredible. Well, why don't you start? That was a great introduction, and I'm really excited. One of the things that we're focused on here on Voices of Video is I really want to begin hosting conversations that get closer to the technical details. So I'm excited that you're working in the area of R&D, and I really want to talk about one of the studies that you have recently completed, but we're going to get to that later, so I don't want to jump there yet. But why don't you tell us what is the core product that Cires21 offers to the market, and what who are your customers? What are the customer profiles for this product?
For this product range that we work on at Cires21, our main market is broadcast, primarily broadcast companies, and we have had multiple partnerships with the likes of BBC, among others, the likes of BBC, Prisa, among others. And our tooling has been validated to work with a lot of their workflows, some of them meeting very specific edge cases that are, well, I wouldn't say hard to describe in this episode, but yeah, it in that direction. And we mostly focus on video. So a lot of our products will be handling video broadcast workflows. This includes the C21 live encoder, the CDN endpoints, and everything else.
Okay.
Yeah.
So you referenced the Cires21 live encoder.
That is correct.
You have CDN endpoints, I guess basically an origin server solution.
That is also correct.
Yeah. What else have you guys built?
We have built, apart from the Cires21 live encoder, we've also built the C21 Live Origin, which is for protocol and transport adaptation and contribution. We also have the C21 Live Editor, which can be used for clipping and editing. And on the distribution side of things, we have integrations with C21 Live Captions, which handles real-time subtitling and translations. We also have we also do a bit of integrations with C21's on Intel AI subplatforms, and this again feeds back into live captioning and other expanding works on transcription and similar workflows.
Interesting.
So from the orchestration, from the source to the distribution to the audience, we have also C21 Live Control, which handles the orchestration processes. And then we also have the C21 Live Cloud with integrations to Google Cloud, AWS, Azure, OVH Cloud, Kubernetes, and others.
Wow.
Yes.
Okay. So I know that you've got some slides that we can go through, and I definitely want to get to those. But just to understand why clients choose to work with you. So you mentioned the BBC, and that's very impressive. I think we all know well that the BBC is a very demanding organization.
Sure.
So is it that you are building things that they're just not able to buy? In other words, you're building solutions that are not available, or are you sort of customizing existing solutions, bringing a few features that are missing? Or maybe you can characterize what it is exactly that why your clients work with you.
Our clients work with us primarily from the very strong reputation and partnerships we have with broadcast, and specifically because the solutions we build for them are typically handcrafted for the kind of appliances and budgets that they have to fit into. So we cannot simply quote unquote repackage something that has worked elsewhere and then just assume that the product will work in another deployment. So like I said, being centered on the R&D front of doing things allows us to handcraft solutions that fit the specific client demands that we have at any given moment in time.
Yeah. I think it's a really good positioning. The requirement of, and this better than anybody, the requirement of each organization is sufficiently diverse. And when I say requirement, I mean the technical requirements, but also the business, and of course those things are related, right?
Absolutely.
But they're sufficiently diverse that it's a challenge that all product companies have. Is that you can have 80% of what any one client would need, but it's that extra 20% that either can be very difficult to deliver or very expensive, or just it's always a challenge because client A, it needs a different 20% than client B, which means that the work you do for client A may not really be usable across other other applications or other clients. So yeah, it's an interesting place. Absolutely. Why don't we go back to your live encoder? I would like to start there, because we are going to have an opportunity to talk about a recent codec study that you published. So I'm sort of teasing that out for the listeners. Don't click off yet, because you're definitely going to want to hear, what Cires21 has found regarding CPU, GPU, and then VPU. Explain your live encoder. Talk to us about what you built, what some of the advantages are, some of the unique features.
So our live encoder was initially built around being able to be as platform agnostic as possible. Any CPU, any platform that we can run containerized solutions on, our encoders could run on. And CPUs are awesome because it is very trivial to tune an encoder profile and presets to the type of workload and throughput you want to run on. And this has been the basis of the encoder for years. And with recent developments and demands on functions to do with both transcode density and also efficiency, we had the need to essentially integrate GPU-based processing and offloading for some of the workflows that we do, and also extending the same encoder capabilities to GPU support. And here I'm referring to the commonly known H.264/AVC. We also have support for HEVC and the up-and-coming AV1 codec. And it's been quite an interesting interplay between the type of quality you want to deliver and the kind of design compromises and constraints you have to take into account when you are adding discrete GPUs into the mix. And the reason being that they also have their own specific software and platform level requirements that you cannot always abstract away, no matter how well you do your containerization and orchestration. So it's been the necessary upgrade, but one that often comes with a lot of R&D into that front to make sure that we are delivering what the market wants and what it demands in terms of both compatibility and retaining the quality that we have delivered consistently over time with CPUs. So that's the most for GPU support,
So can I assume that your CPU-based solution is built around, open source x264, x265, SVT-AV1, or
some of the components are, yes.
Yeah. Okay. Did you actually build your own encoder, or are you using some commercial solutions?
We have at some point integrated some of these open source encoders, and we also have quite a bit of middleware where applicable to offload specific functions and for utility and also for resource monitoring. Yes.
Yeah, exactly. That totally makes sense. So, you absolutely said it right. Software is great when it's running on x86 and it's running in a container. You effectively can run it anywhere, right?
Sure.
Which
It's
gives a lot of advantages. Yeah.
Sure.
I'm curious if you're seeing, what we're seeing and not seeing, we're hearing very plainly from the largest platforms in the world, almost universally. In fact, I don't think there's any that hasn't said, the words. We are, and people are in different phases of this, but basically people want to get off the public cloud. Now, it's not that they want to get off the cloud. So it's not that, everybody, but just the notion of, hey, I'm just going to pay for usage, and, I'm not going to single anybody out, but we know who the 3 or 4, largest platforms are, right? Folks are starting to do the math, and they're starting to realize, wow, like I can go do this either on my own, spinning up my own data centers, or going into colos, or, there's different strategies. There's the hybrid, where you build your infrastructure, but maybe you build it for 80% capacity, and then you flex into the public cloud, different approaches. I'm curious, are you hearing and seeing the same things with your clients and your customers?
That has come up multiple times, and it's something that our products has had to evolve around. The thing about market demands is that they are not bottlenecks. They are more of opportunities to not only realize the next steps that need to be taken, but also the nudge towards building flexible solutions. It is true that the public cloud has never been, the definition for it is that it's not a stopgap to just deploying things you can automate and seeing the results. No, it has implications on billing, availability, and also the kind of resources you can, quote unquote, borrow from a given instance at any given amount of time. So for the customer to then be able to spec out a build on their own in terms of some of the appliances we support, it's important. It's important. The public cloud is not an all-in-one solution. There are places where going hybrid and also retaining compatibility for the edge will matter. The goal is flexibility.
I'm going to steal that phrase. It's not a bottleneck. It's an opportunity, in terms of, like you said, changing market demand or changing behaviors. And I think it's, as a vendor, we have to think of these things too. The market starts to move in a different direction or starts to show signs of adopting, maybe a different set of technologies than we have contemplated. There's always that first reaction of like, oh no, we're kind of going in this direction. Looks like we need to go in the other direction. But there always is the opportunity that goes with it. And I love that perspective. It's a good way to think about it. Sure. So this is interesting because it strikes me that you're out in the market, you're competing against some very well-entrenched competitors who have broadcast solutions.
Sure.
Again, I won't name them, but there's not too many, and everybody knows who they are. So,
sure.
So why is it then that someone would choose, to work with you to adopt one of your solutions and maybe even products? It sounds like you productized, like your live encoder, for example. So why would they choose that instead of just pulling something off the shelf from one of the, the established brands, that are out there?
That's a good question. And I believe the key point to what you just described is something I prefer to call it as fit. We are not here to reinvent the wheel, all right? The goal towards the continuous R&D efforts that we make to building these products are that we are also consumers of the products we make. The concept in software engineering that we term as dog fooding. These are products that we have used in our own workflows to the point that we refine them as a broadcaster would. So we are shipping products to engineering and production teams that not only work like the way we do, but have the exact same problems that we have had to solve over iterations to solve and to also address. And a growing concern here being not only a function of compatibility, but also being able to be what I now refer to as being cloud-agnostic. Cloud-agnostic. Our solutions will run on any publicly available cloud that exists out there. And whatever hardware you have, be it CPU, be it GPU, be it even the NETINT VPU stack, we support that now. Our goal is not about being what you call trending towards being vendor locked and everything. No. We are going to work with some of the biggest cloud providers there are to make sure that whatever resources they have on those instances, we can use them. And we can also create products that fit not only into the budgets, but into the flows for the people that use them.
Yeah, for sure.
Yes,
for sure.
For sure.
Yeah, it's a good, it is the right way. And you answered the question beautifully because I think, sometimes it's easy, depending on where someone is in the ecosystem, what their focus is. So, for example, if an engineer is, primarily been trained in video codec development or codec optimization, or they're just really, really heavily inclined towards encoding, they see everything as like an encoding challenge, and it can sometimes, decisions can get weighted down into areas that are important, but they're important in a narrow band. And when you look at when you kind of step back and look at the whole workflow, there's optimizations across the entire workflow, that can be done, which when you add all those up can deliver a much better result. So yeah, it's interesting. Well, here's what I'd like to hear. I'd like you to talk about your journey from moving from and we're focused again on encoding in this particular discussion, although feel free to talk about other areas of the pipeline of the workflow of your product that you've transitioned from CPU to
Absolutely.
hardware. And the journey being CPU, I know that you adopted GPU, for greater efficiency, higher densities, some of the obvious reasons, even codec support, like live HEVC initially was really hard to do in software. It required a massive machine and you only got a handful of channels, now the situation has changed a lot over the years as X265 has been optimized, and there's other encoders out there that are quite efficient for HEVC. But now we look at like AV1, AV1 in software for live, and to get good performance and good efficiency with reasonable quality is still very, very, very hard. So talk to us about this journey. Tell us, what you've been doing. Walk us through CPU, GPU to VPU.
Definitely. So initially, as stated earlier, our work started by implementing codec support in the most vendor-neutral dispatch methods that we had, and that is on the CPU. And of course, this grew from adopting H264, HEVC, and then at some point we had workflows that also required VP9. Yes, VP9 in software, which is by all means a pain to set up. But that's a topic we will definitely revert back into, because VP9 never really, quote unquote, it never really got the traction that its successor AV1 did. And the reason being, again, platform adaptability for it still remained quite limited, even in areas where you could have done specialty workflows for the likes of WebRTC and co. And even by the time we had chips that could handle hardware accelerated decoding for it, the likes of HEVC and even H264 was still relevant. Now, a challenge we have faced, as everyone else that develops video products will tell you, is that CPUs are pretty awesome for the flexibility they give you. You can push in almost anything and get the output you want, but you are limited, and I mean hard limited by the actual physical resources any given chip can give you, regardless of its size or memory constraints or the storage fabric that you have, because there are goals that require a given amount of density and also a given amount of throughput to be handled at any given time. And this is doubly so when you are doing multiple ABR style ladders. This is average bitrate and multiple bitrate ladders. And this is where GPUs come in. With GPUs, it became then possible to not only drastically increase the footprint of our appliances versus the outputs we can handle, but we could also offload more of these pipelines into the GPUs. I'm talking of scaling, color conversion, HDR to SDR. We call that tone mapping in this field and everything else. We can even handle custom payloads now, because again, doing R&D for this kind of work you'll often find yourself solving problems long before they come knocking at your door. And GPUs opened those doors for us, so that we can not only ship products that are lighter in weight and in chassis builds and everything else, but for the type of throughput they can give you, you also get a higher return on your investment over time. And again, maintaining compatibility with cloud solutions that have these GPUs provisioned on premise.
And I assume, sorry to interrupt, but just for a point of clarity, when you say GPU, you mean NVIDIA. When we're talking about using the encoder in the GPU, you mean NVEnc, right? Or
that is one of them. That is one of them. Our product stack is quite extensive. We even do support Intel's 1VPL platform. Initially, they called it QuickSync. We also support the open source standard called VAPI, the Video Application API. We implement that, and the beauty of these dispatch methods is that with VAPI, anything that has a Mesa compliant driver that can do the offloading, we can support. We also extend a bit of this processing to the open source Vulkan API. And in Vulkan, we can also do video encoding for H.264, HEVC, and even for some of these very edge-based codecs, such as the archival format called FFV1. This has been developed by FFmpeg Labs. It's lossless, but we do have an open source encoder for that works for that codec. So it's an edge case, but it's there and it's implemented.
Yeah, it's there. And And now, are you building workflows? It sounds like it's a mix of contribution and distribution. Is that correct? Or are you kind of more focused on one or the other use cases?
Both all of these use cases are correct, because again, the whole point of GPUs comes down to utility. How much more can I do with a smaller footprint on both power draw and rack density? And that's where GPUs come in.
Do you find, so we're going to get to VPUs, but it's really interesting because just as an aside, I think some people, obviously those who use VPUs and have spent time working with us and using the product know that, yes, on some level, a GPU is a competitor to the VPU. In other words, there could be a scenario where someone would choose to use some NVIDIA card and use the video IP instead of a NETINT Quadra, for example. It almost never happens for reasons that maybe we'll get into later, but it is possible. However, it's interesting. People assume like, well, but aren't you sort of like at war with the GPU, and it's like, no, actually there's some scenarios. We have a very, very large customer, they're in the cloud gaming space, operate a massive platform, but we actually did some very special work with their GPU vendor to be able to pass the frame directly to our VPU without going onto the NVMe bus. It's in memory. It's in the DMA.
That is possible.
DMA,
That's possible.
Peer-to-peer transfer. And one of the reasons that we're able to get the densities for this particular platform that nobody could believe initially until they really understood what we did is because of this. We're able to keep everything in memory, and so we're very friendly, with the GPU vendor. And in fact, the other big GPU vendor who also wanted the business, started calling and how can we work with you? And we're like, wait a second, they're like, no, like right now we're friends, we want to work with you.
Absolutely.
So I'm curious though, are you finding that the GPUs that you want to use, or because GPUs are sort of universal, and NVIDIA has done a wonderful job of building software and supporting software across the ecosystem.
Agreed.
But it's not true that it's just I can just grab any NVIDIA GPU and just use it. So do you find on the public clouds that there's sufficient availability, that the customers basically can get it whenever they want? Or have you had to kind of know, like, hey, platform A is a little bit better than the other platform A, and and they're slightly better than the other platform G, and like
that actually does happen, and I will not even have to mention names. Yeah. It's one of these things where we have what we now call super vendors, big enough to not only have possibly the largest share in not only AI, but also GPU availability in the public cloud, and then also having the tooling to segment these GPUs further into smaller instances. I believe the technology they have for that is called MIG, the multi GPU split. This is not just GPU virtualization. It's a form of negotiation where the driver splits the GPU into multiple partitions. And it is true that if you do not use the tooling as well as you should, you may get partitions that may not have some of these slices enabled. Intel, I believe, had a similar solution back in the day. They used to call it Intel GVTG, and then it was discontinued. It's a bloody mess. It was just dropped dead in the water. And NVIDIA's advantage, I believe, lies in their tooling. But now, asserting the assumption that all this tooling will work in the same way in all these public clouds is another topic of research.
Exactly. Yeah. It's, and look, in all fairness, we deal with, we don't have as much of a tooling issue. In fact, we really have zero tooling issue because, just the way that you would use our product and our APIs and everything that we make available. Also, our product's not general purpose like a GPU is. So, so our issue is not as much tooling, but we do very much have an access challenge, that is, at this point, we're still being built out in a lot of the public-facing clouds. So, with the exception of Akamai is one of the most recent, clouds or edge providers that we can talk about publicly, that's building out. Our challenge also, and it's a challenge of all hardware, is where can I get it? Where is it available? Because it's a physical thing. This again is why software is so great on one level, but then when you begin to scale and build these massive systems, it just doesn't scale. CPUs are just too power hungry. They're too expensive. There's a lot of reasons why they don't work. So okay. So we're going to get to VPUs, but I'm curious, was this move to hardware, i.e. GPU, was it driven just more from like hey, the only way we can do, like 422 color conversion and, do some of these more, deinterlacing at very high quality, and some of these more, is with GPU. In other words, I'm just curious if it was driven more from just a technical, technical reason, like the only way we can do it is with GPU. It's just not really feasible on CPU. Or was it cost? Or was it a combination? Did your customers pull you into it? Did, talk to me about the drivers behind this transition to hardware.
Absolutely. And I believe the greatest driver here has been a term you might have heard me drop a lot in this podcast, and that term is density. Density. density.
Yeah.
Because at no point in time are you going to sell someone a very high capacity server and then just give them a number. Hey, for the type of renditions you want and the inputs and outputs, you can only give you like 10 instances of this. And
Yeah.
there's only so much you can do on
So much
silicon
power and so much
without
rack space, right?
true
That,
before you
yeah.
start running into, and I'm not just talking about memory bottlenecks, but also throughput. A lot of software encoders excel at the reference level. They are
Yeah.
good at producing excellent
Yeah.
bit streams as per
Yeah.
the
Yeah.
specifications. Even
Yeah.
without dropping names, we know who they are.
Yeah.
Now,
Yeah. Yeah.
GPUs excel at offloading some of these functions in a way that you can also
Mm-hmm.
tune out the quality offsets for this, and in a way that
Mm-hmm.
is acceptable for downstream consumption. And these are measurements we have done over time, because your customer will demand a given amount of VQ, visual fidelity, and visual
Mm-hmm.
quality before something becomes viable as a product on the line. And it is true. You simply put, having to offload some of these processes isn't something we developers would want just wake up and say you have to do it. It's a necessity. It is
Yeah.
evolution.
Yeah.
It's
Yeah.
either going to
Yeah.
find you, or you're going to find
Yeah.
yourself buying into these solutions and you will be behind time.
Yeah. Yeah.
Yeah,
Yeah. Yeah.
yeah,
I can so relate to what you're saying, and I'm really happy to hear that you have taken the stance of leading this. I don't even want to say trend, because it's really requirement. And,
yeah,
early in the development, so we've been shipping our VPUs. It's well known, we're in our second generation VPU, and that one has been, now we're coming into the third year of Quadra.
sure,
So it's
sure,
really established. But we've been in the market for, 5 years now. And, there was a good, probably first 3, even 4 years. The situation only changed in maybe the last 12 to 18 months when it started this sort of, but where people would evaluate our VPUs and they would evaluate it against the very best software implementations.
sure,
And I guess on one level, the rationale was, hey, why would I compare it to something that's, just sort of call it average, whatever that
sure,
means. And everybody has different definitions, of course, of like what, good and, okay and bad is, but, just call it average. So they would naturally sort of say, hey, I'm going to compare it against the very best. We know that hardware always performs differently, but so, they would come back and they would usually say, wow, the quality is actually really good, like much better than we expected. But then they would proceed to say, oh, but software, is so much better and beats it here and beats it there and beats it there. And this would happen time and time and time again. And it took a couple years for the market to kind of wake up and go, but wait, in a 1RU server, I can get 320 live channels, even with AV1 or
yes,
HEVC, at quality that is better than what I would typically be doing in software, for live. Now, again, for live, and I would be getting just a handful of channels in software. And so it took like a little while for the market to sort of like figure out that, wait a second, you've got levers. You can dial up quality and bitrate efficiency, compactness, and you're going to dial way back density, right? You can, and
sure,
I'm speaking of in software, and we know all the levers. Everyone works in video knows this. I can also then make choices to dial up throughput so I can get more channels. But guess what? My quality is going to go down in software. It's going to go way down. My bitrate efficiency is going to go way down. But and I have these levers. But with hardware, your scaling is based on physical. How many U.2 or PCIe slots do I have? How many machines can I fit in the rack? It's very, very different. And this is a massive, massive, massive advantage as you're moving through GPU and then to VPU. Is that yes, software is still always going to give you the ultimate flexibility. You can wring every last bit of quality out of it. And for certain applications, it is the right solution. But more and more, we are seeing that people who traditionally held this, shall we say, very, very high bar, and if you didn't meet it or even exceed it, like they didn't want to talk to you, they're now approaching us as saying, we've seen the light of day. Look, our costs cannot continue in the direction they are. We have run out of power in the data center. We have no more power. We have no more rack space, and it's unacceptable to answer to the CTO's office, or my CEO and say, sorry, we just can't expand the service because, we have this high bar for quality and we're not going to let anything go above it or go below it, And so this is, I think, a really important trend. And for those listening, if you're wrestling in your own organization, listen really carefully, to what is happening, because it's not that these trade-offs mean that you're delivering, lower quality. No, in a lot of cases, you're delivering higher quality. It's that this mythical high bar that the industry often would shoot for, and yet no one was actually delivering it, is now gone. And if you can't deliver hundreds of channels inside a single chassis, it's going to be really hard to compete, with those service providers who can. So it sounds like that resonates with you, what I was just saying.
It does. It does. It
Yeah.
absolutely does.
Yeah, yeah. So, with that, then how did you find NETINT? I'm curious, and what's that journey been from moving through GPU and then to VPU?
I understand that the VPUs are essentially what an engineer would call an ASIC. So they are in a very separate. They're in a very separate microcosm of their own, because it's not a GPU. It will never be a GPU, even the way that ASICs implement support for the processing they kind of do. The device behaves like an NVMe or some other specialist bus and then returns the result to you. But it's not a GPU. There are no quote unquote host side drivers or special hooks you have to attach to get it to work. It's simply /dev NVMe 0, 1, 2, 3, 4, as many as you have. And as long as you have the namespace initialized, then boom, you have the technology stack working up and down. And that's it. Now, my introduction to this the NETINT stuff was at the IBC 2023. And this is where I met one of your most brilliant engineers. Unfortunately, it's not a name I can pull out right now. That would be Kenneth Robinson, I believe. Kenneth Robinson.
Yeah. Kenneth was there.
He had this open rack. I think by then the layout they had taken us that they have this open rack showing you like how these multiple modules can fit in on the storage backplane. Maki, this isn't the PCI stuff. I'm talking of like the NVMe storage backplane of
we had a super micro. Yeah, we had a 1RU real run of the mill super micro chassis. Nothing fancy, very affordable. This was not an expensive machine.
Yes, and the module that they were showing then, this would be the Codensity G5.
T1U is what we were
T1U.
showing. T1U.
That's what I remember.
It looks like an SSD, for listeners who haven't seen it. So I'm sorry, I'm just describing, for those who aren't familiar. It literally looks like an SSD. It's the exact same form factor, has really cool, extruded aluminum case and all. I mean, it looks really cool. Just pops in the front to an NVMe slot. You pop the latch and voila, it works. It works.
And I'm here just I'm here looking at this hardware and I'm like, I can count at least 10 slots because the board that NETINT
There were
carried
10
that day,
slots in that chassis that we were showing.
this isn't like the flagship. This isn't a flagship motherboard. No, this is
No.
literally off the shelf rack.
Yeah.
Something that I could possibly put up in my own home lab. And I'm here doing the math on power. Like these cards are supposed to draw anywhere between, I think, 7 watts, give or take.
Yeah, so the T1U draws about 27 watts, something, something like that. So,
But you're here doing the math on the kind of stream density you can get versus the actual form factor you're looking at, and that piqued my interest to the point that I had to drag our CTO over, and I'm like, hey, you need to put your eyes on this because this is the next frontier. I need your eyes looking at this. Just take a look. And we picked up a bunch of brochures then, and then this is the time I went and started actually looking into the kind of product portfolio that NETINT had by then. And then I understood that there was an earlier generation codenamed Logan. Now, I have never had the chance to use Logan, but I have seen some of the documentation. And I think what caught me off guard initially at first is that I thought that NETINT was like any other VPU grade company because AMD and even Amazon themselves have their own lineup based on the Xilinx Alveo stuff. So I wasn't expecting anything that's mind-blowing. I was simply looking at, let's see what these guys have done and the problems they have addressed. And then I go through the Logan. I think that by the Logan is the first generation, the one that does H264.
Logan is exactly. It's H264 HEVC, exactly.
And then on the second day of attending that event, on the second day of attending that event, I remember holding the brochures side by side. And I'm like, I'm looking at the generational jump between the first generation and the second generation. And I'm like, this guy is cooked. Whoever worked on this is someone that understands the kind of problems we are not just trying to solve, but they too have run into this. They are looking at the kind of workflows that, they have solved problems in the present that someone else will run to in the future, and they'll be like, that is the product that we want.
That's right.
Like the generational leap between the Logan and the Codensity G5 is, it's not easy to describe because I have worked with GPUs for years, and I have seen how the likes of NVIDIA typically jump from a generation to a generation, but it does not necessarily imply anything significant as far as tunability, rate control, performance is concerned. Of course, they do have their jumps, but the Logan versus the Codensity G5 jump to me was like, okay, this is interesting. And that's what piqued my interest, the difference in the feature set. Like looking at a product and you can like see the thoughts of the engineer that worked on the problem and came up with a product. This is someone that has run into a problem so unique that you can only solve it adequately on a VPU, on an ASIC. We've had the chance to try this out in our labs. We even have an encoder version that fully supports it, and it's mind-blowing the kind of throughput you can push through something that is sipping power. And I'm talking of literally sipping power.
Again, just to throw out some numbers, I'm glad you're talking about the power and the of course, density, but power, because it is a big deal. people have, it's sort of interesting. We usually, when we start talking to a new company, a new potential customer, you can
Sure.
tell right away, are they primarily being driven by cost reduction? They have budget pressures, or is it power? And there can be a few other things, but it falls really into about 3 or 4 buckets as to what their main motivation is. The beautiful thing is that reducing power, reducing OpEx also cuts your CapEx,
True.
also reduces expenses. I mean, in other words, like, so, I sometimes will make the point, even when someone's like, yeah, of course we care about cost, but we're really, motivated by power, in other words, increasing density, and I'll joke and say, well, the beautiful thing is I'm going to save you a lot of money at the same time, because you can take 9 out of 10 servers either out of the rack, literally decommission them. I'm speaking if you're running software,
Sure.
to do your video encoding, or you can repurpose them. The point is that they're now available for other things, or you just literally, take them out, you decommission them, so it's a beautiful thing. Well, so you have built your own solution.
That is
Are
correct.
you primarily using FFmpeg? Are you using GStreamer? Have you built your own transcoder? Like, what does that
We
look
have
like, the
we
application?
have evaluated all these pipelines all the way from FFmpeg to the GStreamer implementation. And what we have is specifically for NETINT is a solution that's in between. One
Mm,
pipeline, it's good enough for handling on the fly live transcoding. Another
mm-hmm,
handles filtering and filter chains in a
mm,
much more
interesting.
robust fashion. And
Yeah.
I remember you mentioning that some of these deployment challenges with NetInt not having the tooling to do some things, the fancy stuff the likes of NVIDIA
Yeah.
do. And
Yeah.
I believe this is where I can interject to the comment that we've actually found it to be the opposite. We have found NetInt's minimalism towards how they approach the handling of specifically the NVMe namespace to be possibly a blessing, because our containerized solutions do not have to go through an intermediary runner to access the hardware. It's NVMe. As long as the namespace is initialized, you have your stack at the very moment that transcoding command begins. And it is
Mm-hmm.
valid for as long as that container instance or handle is open. And that's the
Mm-hmm.
kind of simplicity that you cannot out engineer. You understand?
Yeah. Yeah.
So for
Yeah.
us, that minimalism has actually been an advantage, because
Has
even
been
the
an advantage.
appliances that you have to build to support NetInt,
Yeah.
their containers are a fraction of the size for what you have to build
Yeah.
to support an equivalent GPU solution. And we are not dialing back on rate control. We are not dialing back
Mm-mm.
on quality. We are not dialing back on
Yeah.
throughput. Yeah.
Yeah, yeah, yeah. Which
So
in
I
software
believe,
you would have to do. Again,
true,
going back to my levers,
true.
example. Yeah. Wow.
Yeah,
Yeah. Thank you. Thank you for pointing that out, because that
yeah,
is true. And that scaling, sometimes we don't talk about it enough, or
true.
it's not. Yeah. Okay. Well, Dennis, this has been amazing conversation, but I don't
Sure.
want to end yet, because you're about to release a blog post, and in fact, at the time that we publish this episode, it'll be live. We'll make sure to put a link to the blog post. But I would like for you to give a high level overview of some of the results, because let's face it, there can be cost advantages, power advantages, but
Sure.
if the encoder fundamentally can't get the job done in the best
Sure.
way, then
Sure.
it still may not be usable, or it's certainly not usable by everyone. But I
Sure.
think you found a different result. So yeah, why don't you talk to us about the study that you did?
Absolutely. So for the most typical flow that we have in terms of ensuring a CBR style play out, a low latency GOP preset, a fixed keyframe interval, and also being able to signal a stream that is highly resilient against packet losses. In this case, we have to signal HRDs, these are hypothetical reference decoder signaling. We also have to handle repeated headers. We also have to handle access unit delimiters for H.264 and HEVC. And also in AV1, your encoders implement support for AV1 error resilient encoding mode. And in our extensive testing, it has no performance impact. And for quality retention, we also have access to tuning knobs for long-term reference frames. They call them RTRs. And these are enabled in all the tests. And we also have compatibility on some of these restricted encoding profiles for the, let's say, baseline in H.264 encode, where you can then limit the length of the long-term reference frames to 1 instead of entirely disabling the feature set. And it is based on this flexibility in being able to tune this encoder that these results were generated. And what immediately stands out here is that this is an ASIC. So we cannot therefore do direct VMAF to VMAF scoring for workloads that have had scaling applied to them. By scaling, I mean you have taken a source like 4K and downscaled it down to something like 1080p and core, and then assume that an ASIC will then give you a similar result to a discrete GPU solution that has all these silicon blocks for scaling. On the ASIC, I understand that it's implemented differently, but regardless of the exact numbers we have here, and this is something we have done with roughly 1,500 samples. We have an entire lab set for these samples. The visual quality scores and the BD rate curve for what NETINT does is consistent. There is virtually no perceivable quality loss from any distance or from any device that has been used to view the content that has been encoded and downscaled and encoded with these VPUs compared to the GPUs, regardless of the minor point scores compared to a GPU implementation versus the VPU, because the delta here between the GPU and the CPU for especially the 1080p ladder can seem a bit skewed because we have difference points of about 7. And then again, when it comes to 720p, now this is where the VPUs absolutely shine. They blow everything out of the water. And going straight to the score summaries, for HEVC, we observed the best performance at about 720p, which gave us an aggregated mean score of 81 points, followed closely by 1080p at 79.58. This is again explained by the scalar implementation that NETINT does, and again at that power capex that they operate at. Now, as expected, and also which is also conformant with the other platforms we've tested on, the quality degradation, even at extremely low resolutions, remains acceptable and is also comparable to software encoding. And of course, as expected, the lowest tire ladder at 360p variant scores about 55.15 points. And then for HEVC, it mirrors about the same performance number trends as HEVC, with I think a different score is just -1 for both ladders. Again, it has minimal quality degradation even at extremely low resolutions compared to H.265 HEVC, and is again comparable to the equivalent software encoder, that's LibX264. And as expected, the 360p variant, which is the lowest ladder we have, scored the lowest, which is about 54. And again, now we go to AV1, and this is where the ASIC shines. This consistently delivered the best scores across resolutions, And again, tops out at about 720p with a good 81 points, and at 1080p, scoring slightly shy of 80, 79.65. And then we also have extremely strong performance at the very low tiers, 576p and 360p, compared to the other codecs. And one of the biggest highlights about these VPUs as related to encoding demands and efficiency is that compared to the software equivalents and at extremely low resolutions where someone would have possibly wanted to switch to a software encoder, they perform extremely competitively. Now, this is a result I did not expect, because the GPUs here absolutely, they fail. I wouldn't call it like a fail, but it's much lower than their software gearing. But the VPUs hold out on their own here. So for the guys that are saying, hey, we want density at a scale that's targeted for, say, mobile content, and I also believe this is related to the companies that would possibly do a lot of these live events and gaming and stuff, where you have bandwidth constraints that need to be taken into effect. These VPUs are performing at a level equivalent to the software encoders, and at the lowest solutions. Now,
that's right.
We also have access to the CUDA accelerated VMAF scoring engine developed by Netflix. And we have been able to also, just for an experiment, run it against the NVIDIA's proprietary scaling algorithms to see the kind of quality degradation the different scoring methods would likely impact what we observed with NETINT. And the scalars that NETINT use actually meet the kind of scaling that the VMAF scoring expects, because the scores, again, across multiple runs are identical. The differences are in they are in the second decimal place. So it's virtually identical across multiple runs. And again, the direct implication here is that the scalars that the NETINT VPUs have are going toe-to-toe with a GPU-based scalar for a fraction of the power. Now, that is not a result I can explain right now, because it's something I still have to go to the lab and continue running this test. But that's an observation I have made.
Yes. For sure. Now, one question I had is, what was your anchor quality target? Maybe you said it and I missed, but when you were comparing CPU, GPU, VPU, and the library of 1500, a lot of times people will choose like maybe medium or slow or fast. They'll kind of choose some quality target to anchor. Did you choose a quality target?
Absolutely. But again, when it comes to video encoding is a craft. I would not trust a preset to dictate the kind of settings I want preserved on a given bit stream. And that's why when I started the conversation about the VMAF scoring that we have here for the specific encoders, I mentioned the knobs that we touched and what we did not touch. And I typically do not consider presets to be a good starting point when you are tuning footage for a specific score.
And by the way, I completely agree, but I guess my question is slightly different. It's just, for point of reference, when somebody's looking at this data, would that be comparable to, like an X265 medium, roughly, or X265 slow, or is it fast or faster? Which preset?
You are looking at medium, but with a restricted look ahead. You have to set a given number of look ahead frames.
That's right.
In software mode. Because again, the software encoders can be very plausible at anything below medium. At that point, you're just wasting CPU power.
That's right. That's right.
So for the question that you raised, yes, if you are comparing this against a software encoder without even touching the settings, the VPUs are holding out their own.
Yeah, yeah,
Yeah.
absolutely. Well, that's good. Well, yeah, thank you for sharing this. And, we will definitely link up to the blog post. And of course, we'll be promoting it.
Sure.
Also, I would be really remiss if I didn't point out that you are actually going to be in our booth at NAB. And
Absolutely.
we're doing something very special this year. You're one of the first 5 inaugural companies to join us. I think this is going to become a regular part of our trade show presence moving forward. But yeah, we're really
Absolutely.
pleased that you're going to have a kiosk. You'll be showing off, your solutions, and obviously in the context of NetInt. So I do want to invite all the listeners, if you're coming to NAB, odds are you'll stop by and see us, but make sure you say hi to Dennis, and make sure, you talk to Cires21 as well. And, you can learn more about what they're doing.
Absolutely.
So, yeah, super. Well, Dennis, I know that we could easily extend this into a 2-part, and I know you have more to share, and I actually think maybe we should follow up
Sure.
with a part 2 to this. But we've gone over, and I guess we probably should wrap it up.
Sure. We should.
So yeah, thank you again for joining us on Voices of Video. It's been a wonderful conversation.
Thank you so much for hosting me. It's also been an extremely wonderful and, I dare say, eye-opening for me too.
Excellent, excellent. Well, good. Well, thank you so much.